Hello and welcome to section 9.7. So we're going to continue graphing quadratic functions, but we're going to graph by transformations. So as opposed to properties. So we're kind of going to look at the function in different ways in terms of, well, if you know the basic quadratic shape. Okay, so we're going to look at the simplest possible quadratic, which is y equals x squared. Then certain things to the graph. So we're going to go through a series of transformations. Like what happens if you add and subtract a number at the end after the x squared? You're going to see that that's going to move the graph up and down. What happens if you add and subtract something directly from the x in parentheses and then you square it? This is going to move the graph left and right. So this is up and down, this is left and right. What happens when you multiply by a constant? So this is going to stretch it or compress it or flip it if a is negative. So, and we're also going to look at combinations of things, okay? So we're going to start by looking at the effect of adding a constant at the end. So we're going to look at functions of the type f of x equals x squared plus k. This k could be positive or negative, it's just a number, right? So we're going to draw three graphs on here. First x squared, then x squared plus 2, and then x squared minus 2. Right? So we're going to do a tables of values. Okay, this will kind of get us used to what the functions look like. So we're going to graph y equals x squared first. We have 0, 1, 2, negative 1, negative 2. We plug in, we get negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Okay, so this is the most basic parabola graph. Vertex at 0, 0. 1 squared is 1, 2 squared is 4. Negative 1 squared is 1, negative 2 squared is 4. So you're kind of squaring all the x. You can put in more. You can have 3 squared is 9, negative 3 squared is 9. Okay, so this is our basic parabola graph. Everything is based on this one. Alright, now let's make the next graph. We have y equals x squared plus 2. Alright, so what happens this one, we're going to use the same x values. 1 and 2. So here we're squaring and then adding 2 at the end. So we're going to square negative 2 and then add 2. So we get 4 plus 2 is 6. We're going to square negative 1 and add 2. So we get 1 plus 2 is 3. Square 0 and add 2. We get 0 plus 2 is 2. 1 squared plus 2 is 1 plus 2, which is 3. And 2 squared plus 2 is 4 plus 2, which is 6. So notice that what happened with these values, it's the same as these ones, but we're adding 2 to each of the y values. Okay, so they're shifting up by 2. Okay, so if I go 0, 2, 1 is 3, negative 1 is 3, 2 is 6, and negative 2 is 6. Okay? So it looks as the same shape, but all the y values got increased by 2. So it's kind of the graph shifted up 2 units. So x squared plus 2. Right? Now we're going to do the next graph, y equals x squared minus 2. 0, 1, 2, negative 1, negative 2. I bet you can guess that everything is going to shift down by negative 2 because we're taking these values that we found in the original x squared graph and we're subtracting 2 from each of them. It's going to be like 4 minus 2 is 2, 1 minus 2 is negative 1, 0 minus 2 is negative 2, 1 minus 2 is negative 1, 4 minus 2 is 2. Okay, so let's see, we have 0, negative 2, 1, -1, and -1, -1, 2 and 2, and -2 and 2. Right, so we draw the parabola, and we see that it looks the same, but everything is shifted down 2 units, x squared minus 2. Right? So this is what happens. So if you have x squared plus a number, this is going to shift the graph up that many units. If you have x squared minus a number, then it's going to shift it down that many units. Okay? But the basic shape is preserved.